Hey guys, so in our last lesson we talked about momentum. We talked about what momentum is. We learned the equation P equals mv, momentum equals the mass times the velocity. And today we're going to go a little bit further, and we're going to talk about what's called the impulse momentum theorem. And our target for today, we want to be able to use the impulse momentum theorem to solve some problems. So let's go ahead and let's talk about what that means. Okay, so first thing, impulse. Impulse is it's not really a new concept, it's just a new word here, right? Impulse is just the change in momentum. Most things we would just say the change in whatever, but for some reason, I don't know why, we give impulse its own name. Impulse is just the change in momentum. So like with velocity, if I'm talking about velocity, I call it v. If I'm talking about the change in velocity, I call it delta v, right? With momentum, it's p, if you recall. So change in momentum is delta p, and that's just what impulse is. It's delta p. It's the change in momentum. We just give it its own name for some reason. So just like momentum, we'll measure with the same units. It's a kilogram meter per second. So that's what momentum is. Momentum. Okay. If you think about an object whose momentum is changing, okay, it's probably speeding up or slowing down. Its velocity is probably changing, and that's what's changing its momentum. In order for an object to speed up or slow down, it requires a force. So a force has to be working on it for it to speed up or slow down, right? So force is a component of the change in momentum, the impulse. If you think about applying a force to an object to speed it up or slow it down, the amount of time that you apply the force to the object also is a factor in what's going to happen, right? So the time is also a factor in the change in momentum, the impulse. So you can find the change in momentum, the impulse, delta p, by taking the force times the time. Remember, force is newtons, time is seconds, so delta p is going to equal F times t. Okay, now we've learned that momentum p is equal to the mass times the velocity, p equals mv, right? Usually, when an object's momentum changes, it's usually not the mass that's changing. Sometimes you get into situations like that, like if you think about a rocket. As a rocket goes up, it burns its fuel, it speeds up, but it's burned its fuel off, and it's expelled gases, so its mass is now less, right? But usually, with most objects that we talk about, it's not the mass that changes. It's the other component. It's the velocity, right? So for these kind of situations that we can talk about, the change in momentum will be the mass times the change in velocity, because it's the velocity that's changing, not the mass, right? So we could say that delta p equals m delta v, right? So the change in momentum is equal to the mass times the change in velocity. Now, we also just talked about that the change in momentum, delta p, is equal to the force times the time, ft. So if delta p equals ft and delta p equals m delta v, that you can go back to your algebra properties. I believe it's the transitive property, and you have two things that are equal to the same thing, so that we could say that the force times the time, ft, is equal to the mass times the change in velocity, m delta v. So ft equals m delta v, and that is what we call the impulse momentum theorem, and this is the equation that we want to learn how to use today. Okay, let's have a look at an example of how to use the equation. Now, when you're using this equation, when you want to go ahead and solve the equation, this is usually going to be 2 steps of algebra to solve. So let's go ahead and take a look at how we would do this. Okay, the example, it says a 1,400 kilogram car moving westward with a velocity of 15 meters per second collides with a utility pole and is brought to rest in 0.30 seconds. Find the force exerted on the car during the collision. Okay, so just like really any problem, I'm going to start off by listing the things that I know and what they asked me to find. Okay, so the first number I see in the problem there, it says 1,400 kilograms. Kilograms tells me that's the mass. So m equals 1,400 kilograms. The next number I see is 15 meters per second. Now this car is going to go from 15 meters per second to 0, right? It's going to stop. And so its change in velocity is 15 meters per second. So that's delta v. So delta v is 15 meters per second. Okay. The next number I see there is 0.30 seconds. Well, seconds is the time, right? So t is 0.30 seconds. And the question said, find the force. So F is what I'm looking for, right? Okay, so now that I know what everything is, I'm going to apply the equation we just learned, Ft equals m delta v, and I'm going to put the numbers into that. So F is what we don't know. I'm going to leave F there. And t, time was 0.30, so F times 0.30 equals, m was 1,400, and delta v was 15. So on the other side here, we've got 1,400 times 15. Okay, so what I'm going to do first is I'm going to multiply that 1,400 times 15, and I am going to kind of make the other side, f times 0.30, look a little bit more standard, what we're used to. So I'm going to put 0.30 times f equals 21,000. 1,400 times 15 gives you 21,000, right? And now what we'll do is we'll just divide to solve the equation. So I'm going to divide both sides by 0.30. And that leaves me with f on the one side, and 21,000 divided by 0.30 gives you 70,000. And this is a force, so we're going to put the unit in newtons. Now, if you look at your numbers there, we need two significant figures in this answer. Both 0.30 and 21,000, they both had two significant figures. And 70,000 only has one, right? So sometimes what you can do, you could put the number into scientific notation if you know how to do that to show two significant figures. Or sometimes what people do is they'll just underline a 0 that's significant. So we can just underline that 0 after the 7 just to say it's significant. So 70,000 newtons is our answer there. Okay, so there's a little bit about the impulse momentum theorem and how we use it. Ft equals m delta v. Hopefully that helps us be able to use the impulse momentum theorem to solve problems. So see you next time.